Shalom. And I'm afraid that's all the Hebrew you're going to get out of me tonight because despite the fact that I've been coming to Israel, what happened? You need me to attach it to my left nostril? I hope I'm audible. I've been coming to Israel since about 1971, and although it's not frequent, sometimes it's 10 years in between, I've been watching the country as it has grown, as the buildings have been shooting skyward, as various and sundry challenges have arisen and you've overcome them. I was asked at one point, how do I think about this country and its people? And if I had to summarize it in one phrase, it would be against all odds. That somehow, in spite of everything, you've succeeded, you've survived, and you've thrived. And it's a really wonderful symbol for the rest of us. So I always enjoy coming back to see what's happened and what's new. I'll try to, I'm sitting here, this is like a cabaret. I feel like I should be singing, but you would not want to hear me singing, so I won't do that to you. But I hope I can say a few things that will be of interest. We're going to do a little Q&A, and at the end we're also going to have an opportunity for you to ask questions and raise issues that I hope I'll be able to respond to. But let me say a little bit about what I have observed just in the last couple of days. The first thing is that I've had a chance to meet with a number of young, that's sort of everybody, because I am older than everybody I meet these days, young entrepreneurs who have ideas that they want to pursue. They have found ways to fund those ideas. They have found ways to assemble teams of people to pursue them. And I've been, frankly, also very pleased to discover how many of them have been able to use the internet as a platform for achieving some of their objectives. One of the reasons that I'm at Google is that after spending many, many years building the plumbing of the internet, I got very interested in the applications of the internet, and I couldn't think of a better place to come than Google to explore what might be possible. So some of the philosophy of the company I think is very important for everyone here to think about. One of the important elements at Google is a tolerance for failure. Now, it's not that we want people to fail. It's that we want people to try to do things that have a potential risk of failure. And the reason for that is quite simple. If you don't shoot for the moon then and make an attempt, if you only try to do incremental things, that no big things will happen. And it's much better to try for a really big moonshot and maybe not make the moonshot, but do at least something significant. So we have a group at Google called Google X, and their job is to do moonshots. And you've seen a few of them. The self-driving cars are an example. Another is Google Glass. Another is Project Loon, the balloons that are up in the stratosphere supplying Wi-Fi services to people on the ground who otherwise wouldn't have any connectivity. And there are a bunch of other activities in that space that we're not yet able to discuss in public. But the whole point here is that the company is willing to allow that kind of stretch initiative, even though there is a possibility that it won't work. In the meantime, we're also very committed to providing open access not only to the basic services of Google, the search engines and the Google Docs and so on, but we also are giving away software, and we do that for several good reasons. The first one is that when people get their hands on open source software, they have an opportunity to do something with it. They can change it, they can adapt it. We don't make any constraints on that. And so you're seeing an awful lot of Android phones coming out because, or even Android tablets and other things, because the software is freely available in source form. The same is true of Chrome and the Chrome browser, Chrome operating system. This has another salient benefit for people who are interested in how operating systems work. To get your hands on a live operating system that does work and to learn more about how it works, and maybe even come up with some ideas about making it work better, or maybe discovering a place where it doesn't work right and it might be a vulnerability. And we pay people, by the way, for finding vulnerabilities in our software so we can make it more and more secure. All of this kind of openness is important to the company's philosophy. It's also turned out to be very beneficial for people who want to build applications on top. So if you've used Google Maps or Google Earth, you know that if you have geographically indexed information and you want to share it with others, you can do it through these platforms that create for you a way of presenting the content in a very easily assimilated way. We're also known as a big data company, and we spend an awful lot of our computing power analyzing and presenting and formatting large quantities of information, ranging from indexing the entire World Wide Web to processing large-scale databases that we use for natural language processing. It's another example of where we've gotten over the past 40 years, not at Google specifically, but in the computer science community. So let me take you back to the 1960s for a moment in natural language processing. I'm at Stanford University, and we have this naive idea that somehow if you just put the dictionary into the computer, for a two-language dictionary like Russian and English, that the computer will be able to translate from one language to the other. So we put in the Russian language and the English language dictionary, and then we present it with a typical, simple English expression, out of sight, out of mind. We translated it into Russian, then we translated it back into English, and it came back, invisible idiot. We said, okay, I guess we have some work to do here. The context needs to be provided. There were a number of other similar kinds of funny outcomes. In the end, it turned out that you needed, first, a lot more than a dictionary. And second, we discovered that statistics turned out to be our friend. I promised I wasn't going to go too geek on everybody. I got warned about that. But there is this guy back in the 17th century who came up with a very interesting statistical theorem that allows you to make decisions based on partial information. And it was ignored for quite a long period of time. But when you think about doing translations, often you have only partial information on which to base the translation. If you have a large number of documents in two different languages that purport to be the same, pairs of documents that purport to be the same document in two languages, if you have enough corpus, you can begin to use statistical matching. This phrase appears statistically to match that phrase. Now, the mathematics behind this are called Bayesian analysis or Bayesian probability. We use this in order to improve the quality of our translations. Now, some of you might have Android phones. Some of you have actually tried to speak to the Android phone to ask it to Google something or ask it for directions. And a lot of the time it works. Sometimes it doesn't. But a lot of the reason that it works is that we have a large corpus of spoken English, or in fact now other languages, although I'm not sure we've done Hebrew yet. Do you know? We have. Okay, so we've got enough corpus of spoken Hebrew as well. So we are using these tools in order to make it possible to communicate by voice with machines or to translate text. So if you're using Gmail, for example, and in my case, if I receive a message in a language I don't happen to speak, the system automatically recognizes languages and asks me, would you like me to translate? And although it's not perfect translation, it's often enough to figure out that it's an advertisement from some guy in Nigeria who wants to give you $10 million. I'm very proud of the fact that we have managed to get well beyond the out of sight, out of mind, invisible idiot problem to useful kinds of translations. Let me say one other thing about Google Glass, because a lot of people have gotten nervous about the possibility that it's an invasion of privacy. There isn't any difference between the Google Glass, which looks like a pair of glasses with a little television display up in the upper right-hand corner here, and strapping a mobile to your forehead. The functionality is the same. It's just that it's a lot less comfortable to wear a mobile strapped to your forehead than it is to wear a pair of Google glasses. Google glasses. But I want you to understand why this is turning out to be so interesting. The Google Glass is a device that lets a computer see what you see and hear what you hear. And so it's bringing the computer and all the computer power of our networks and systems to bear within a context. So let me give you an example. Let's suppose that we have a blind German speaker and we have a deaf American Sign Language speaker, and they want to communicate with each other, and they're each wearing Google Glass. So let's see what happens. The blind German speaker says, Guten Nachmittag, ich heiße Vint Cerf. And the deaf guy, of course, doesn't hear that. But the Google Glass microphone picks up the German expression, translates it into English, and then presents it as captions or as written text for the deaf guy to see in his little Google display, the Google Glass display. And now the response is signing, which the blind guy can't see, but the Google Glass camera that he's wearing sees the signing, translates the signing into English, translates the English into German, and then speaks the German using a bone conduction speaker that the blind guy is wearing. So the two are now communicating with each other in spite of the fact that their natural modes of communication are inimical. Now, I've actually overplayed this a little bit because I don't think we can do almost all of that. I'm not so sure we would do too well with the recognizing sign language yet, but I've been told that this is not completely out of the question, that it's something that could conceivably be done effectively over a period of the next 3 to 5 years. So these are the sorts of things that get me excited because it's bringing a computer into your context and allowing it to become a partner in the exchange as opposed to a tool that you have to go instruct. Isn't a very, very interesting exploration. So even if Google Glass isn't a product, although we currently are thinking that it could be made into a product by sometime next year, it still is a platform for exploring some very powerful artificial intelligence notions. Now, I promised that I wouldn't go on, but since you've got this wonderful display of planets here, I feel compelled to give you a quick update on where we are with the interplanetary extension of the Internet. It turns out that about 15 years ago, when Google was first being started, several colleagues of mine at the Jet Propulsion Laboratory were celebrating the arrival on Mars of a Pathfinder robot. It landed in 1997, and it was mobile, and it was transmitting data directly back to Earth from the surface of Mars. And as we began to think about the future Mars missions of more ambitious robots and orbiters, we got to thinking that maybe we needed more than point-to-point radio links in order to support interplanetary communication, manned and robotic space exploration. So we thought, well, you know, Internet worked pretty well on Earth. Maybe we can make it work on Mars. And in fact, we could do that. The problem is that we couldn't figure out how to make it work between Mars and Earth. And without going into a whole lot of technical details, there were two basic problems. One of those problems is called flow control. Basically, the way the Internet protocols work is that when you're transmitting data to somebody and they run out of room, they send you a message saying, stop, you know, I'm out of room, please don't send anymore. And if the time it takes for that signal, the stop signal, is a few hundred milliseconds, then the recipient of the data can actually buffer a little bit and then not get any more until he says, I can receive more now, you can start transmitting again. So it's a nice interactive handshake. The problem is that between Earth and Mars, the distances are so big that the minimum time it takes for a radio signal to go from Earth to Mars is 3.5 minutes. The round trip time is 7 minutes. And since Earth and Mars are moving in their orbits, the maximum time between Earth and Mars is 20 minutes one way or 40 minutes round trip time. So you can imagine saying stop, and the guy on the other end takes 20 minutes to hear stop, and he's transmitting at you at full speed. For 20 minutes, the packets are all falling on the ground. Doesn't work. So we had to invent a new set of protocols to accommodate for that. The second problem is planetary motion. The planets are rotating, and we haven't figured out how to stop that. And so if you're talking to something on the surface, the planet rotates, and after a while, you can't talk to it because it's on the wrong side of the planet, and you have to wait till it comes back around again. And the orbiting satellite's the same problem. So we have disruption as well as variable delay. So we had to develop a new suite of protocols. Well, we've gone through 4 iterations of the design. These implementations of these interplanetary protocols are on the International Space Station. They're, of course, operating here on Earth. They're on the rovers on Mars and the orbiters on Mars, and they're also in a spacecraft that's in orbit around the Sun called Epoxy, which has visited 2 comets in the last decade. So we actually have a small interplanetary internet in operation today. And what we're doing now is standardizing those protocols and in the Consultative Committee on Space Data Systems, so any spacefaring nation will be able to use them. They're freely available, they're open source code, anyone can adopt and use them. And by the way, you don't have to be a space agency to use them. It turns out these are also potentially very useful on the ground, especially with mobiles. Now, those of you who carry mobiles, which is basically everybody in the room, have noticed that sometimes you're not in good connectivity with the mobile base station. The interplanetary protocols are very comfortable with the possibility that there's a disruption in service. They don't get all in a tizzy about it. They just say, okay, it'll take a while and the connectivity will come back eventually. And so the protocols are very tolerant of this kind of disruption. Personally, I think that they belong in the Android world, and we have people who are looking into implementing that so that you'll have a tolerance for potentially disrupted communication. This can also be really helpful in cases where we have emergency communications needed after serious natural disasters. The base stations are no longer accessible. They either run out of power or they're underwater or they've been destroyed. Having the ability to recreate communications in this kind of disrupted environment will turn out to be important. Well, there's lots more to be said, but I'm not going to say it. Instead, I'm going to ask you to come up. Let's have a conversation, and let's be sure to leave time for people who have assembled here to weigh in with their ideas and questions. The last observation I'd make is that you've all just demonstrated my favorite theorem, number 208, which reads, if you feed them, they'll come. And here you are. So let's keep going. And in any case, thanks for coming tonight.